4.3 solving proportions. I can solve proportions.
All right, ladies and gentlemen, we are solving proportions in today's lessons. First of all, a proportion is how many fractions that are equal. Everybody. 2. So proportions are equal fractions. Now, before I scroll down, can somebody give me another name for a fraction? What is the fancy name for a fraction, Ismail?
Ratio.
A ratio. So when you see ratio, it's a fraction. When you see fraction, it's a ratio. Okay, and then bubble, this is not new, this is a review. We use the bubble method to either reduce or enlarge fractions. Everyone repeat after me. We use the bubble method to reduce or enlarge fractions. So in this instance right here, did we make the fraction 2/4 bigger or smaller?
Smaller.
We made the number smaller. The fraction actually stayed the same. In this situation, do we make 2/4 bigger or smaller?
Bigger.
Because we multiplied, right? So division shrinks, multiplication enlarges the numbers. Okay? That was our cheat sheet idea too. Proving proportions. In order to prove that 1/3 and 3/9 are the same, what do you have to do with the denominators, you guys? In order to get 1/3 and 3/9, in order to prove or disprove whether or not they're the same, what must we do with the denominators? Yusra? Not multiply, not divide. We have to get them the same. Then you got to just decide how to get them the same. Okay, so we know that 3 and 9 both have a common multiple of 9, right? Once we establish that, we make our bubbles. How do we get from 3 to 9? You times by what? 3. So if you times the bottom by 3, what do you multiply the top by? 3. How did we get from 9 to 9? By what? 1. So if we multiply the bottom by 1, we multiply the
Top by 1.
and we get 3/9. So is 3/9 equal to 3/9?
Yes.
So is 1/3 equal to 3/9?
Yes.
Because 1/3 and 3/9 are the same thing. So how do you prove proportions? You get common denominators. Remember, this was kind of a key for the class that just did this today. If you have a hard time doing that, if you can't figure it out, you could actually draw a picture like we did on number 6. We drew a picture of what 1/4 looks like. We drew a picture of what 2/8 looks like. We can see they're proportionate. Right? Right?
Yes.
And then down below, we seem to do a lot better job on this part, missing numbers and proportions. Again, using the bubble method. So we gave you 1/4 is equal to x over 8. How do you go from 4 to 8, you guys?
4 times 2.
Everybody, how do you go from 4 to 8?
4 times 2.
You multiply by,
2.
so if you multiply the bottom by 2, you multiply the,
Top by 2.
and what do you get? 2. Okay, number 8 is pretty similar. Number 9, we have 12/24 is equal to x over 2. So I'm going to rewrite this problem. Number 9, what you first saw was 12/24 is equal to x over 2. Do you know how to get from 12 to x? Yes or no?
No.
Not right away. Do you know how to get from 24 to 2?
Yes.
How do you get from 24 to 2?
12. Divide.
You divide by,
12.
so what do you divide the, what do you divide the top by?
12.
And what does x equal then?
24. 244.
What is, stop yelling out. Think first. So if we divided by 12 to get to 2, and we divided by 12 at the top, what is 12 divided by 12?
1.
So what does x equal?
1.
1 is equal to x, yes or no?
Yes.
Last one we did in the class. Ignore the red on number 10. Do we know how to get from x to 4?
No.
Do we know how to get from 9 to 18? So we bubbled it. How did we get from 9 to 18? Multiplied by?
2.
So if we multiply the bottom by 2, we multiply the top by?
2.
So the question is, what times 2 is equal to 4?
2.
What times 2 is equal to 4?
2.
2 times 2 is 4, right? So x is equal to 2. Questions?